Welcome to the DIY Honda Garage channel. The DTC P0299, indicating a turbocharger underboost problem, pertains specifically to the Honda CR-V models from 2023 and onward. This diagnostic trouble code signifies that there is a significant deviation between the target boost pressure and the actual boost pressure produced by the turbocharger. The Powertrain Control Module, PCM, is responsible for monitoring this pressure and has identified an abnormality due to the detected difference being outside an acceptable range. Components involved include the turbocharger, wastegate actuator, various boost system segments, and several valves in the emission control system. Understanding the location and function of these components is crucial for effective troubleshooting. For instance, the turbocharger integrates tightly within the engine's exhaust system, while components like the evap canister purge, valve, and the boost systems are positioned along the air intake pathway. The P0299 error indicates a problem with the turbocharger's ability to generate the required boost pressure for optimal engine performance. The turbocharger plays a critical role in compressing the incoming air, which is then fed into the engine cylinders to increase power output. Affected components include Boost System 1 and Boost System 2, which carry air from the turbocharger to the throttle body. Both systems must function without leaks or blockages to maintain proper air pressure. The Powertrain Control Module, PCM, continuously monitors the differences between the specified target boost and the actual boost pressures. If this difference exceeds predetermined thresholds, the PCM triggers the P0299 DTC. Consequently, understanding where these components are located in the engine compartment is vital for executing a thorough inspection and diagnosis of the issue. Several factors can contribute to the P0299 error code. First, leaks within the evaporative emission control purge system can lead to pressure inconsistencies, affecting the overall boost pressure the turbocharger can provide. Another cause is blockages or restrictions found within the Boost System 1 and Boost System 2. These blockages can stem from poor connections, damaged hoses, or even a misaligned installation of components. Additionally, any leaks within the exhaust system can negatively affect the turbocharger's efficiency, contributing to underboost conditions. It's important to address these possible causes methodically, starting with visual inspections before proceeding to more complex tests. Understanding these causes is central to rectifying the problem effectively. Symptoms associated with the P0299 DTC can range from noticeable performance issues to operational warnings. Drivers may experience a significant reduction in engine power, making acceleration sluggish and less responsive than normal. A common observation is turbo lag, where there are delays in power delivery during acceleration, often particularly noticeable when overtaking or merging onto highways. Additionally, the vehicle's check engine light will typically illuminate, indicating an ongoing issue that requires attention. These symptoms may arise from the turbocharger's failure to deliver the expected boost pressure, underscoring the need for immediate investigation and resolution of the underlying problem. Knowing these symptoms helps in the identification of the issue before diving into the troubleshooting steps. The first step in troubleshooting the P0299 DTC involves starting the engine and holding the RPM at 3,000 without loading it, meaning the vehicle should be in neutral. It is essential to maintain this engine speed until the radiator fan activates, which indicates the engine is reaching standard operating temperature. This process allows the technician to record the engine's dynamic behavior and performance parameters, such as vehicle speed, engine coolant temperature, ECT Sensor 1 readings, and the manifold absolute pressure, Map sensor data. Checking these conditions helps establish a baseline for normal operation, offering clues to whether the turbocharger and associated systems are functioning as expected. Utilizing this diagnostic approach aids in identifying discrepancies and focusing subsequent inspections. The second troubleshooting step requires a thorough inspection of the air cleaner element. This component is responsible for filtering the incoming air into the engine, preventing contaminants from entering the intake system. If the air cleaner element is clogged or excessively dirty, it can restrict airflow, ultimately affecting the engine's performance and potentially causing boost issues. During the inspection, look for any blockages, tears, or deformities that may hinder airflow. If any deficiencies are found, replacing the air cleaner element becomes essential before progressing to other inspections. A clean air intake is fundamental for optimum turbocharger performance, making this step crucial in addressing the P0299 code. Third, inspect the turbocharger bypass control valve, which is integral in managing turbo performance. This valve helps regulate the flow of exhaust gases to the turbocharger, influencing the boost pressure produced. The inspection should focus on validating the valve's operational integrity. If the valve does not open or close correctly, it may lead to underboost conditions, as it can restrict proper flow to the turbocharger. A visual inspection followed by functional testing should be conducted. If the valve fails to operate as intended, it will require replacement. A correctly functioning bypass control valve is critical to maintaining appropriate boost and overall system efficiency in the turbocharged engine. Moving on to the fourth step, the evap canister purge valve must be inspected to ensure it operates without faults. This valve plays a crucial role in managing fuel vapors from the evap system, and any malfunction can potentially lead to pressure inconsistencies in the turbocharger system. A thorough inspection entails checking for leaks and verifying that the valve can open and close correctly when commanded by the PCM. If leaks are identified, or if the valve does not operate as required, replacement is necessary. Ensuring the evap purge valve works properly helps maintain the integrity of the intake system, which is critical for achieving the desired turbo boost levels. The fifth troubleshooting step focuses on the entire evap purge system, necessitating a comprehensive leakage inspection. Look for signs of leakage in the hoses, pipes, and connections within the system. Specific areas to monitor include joints and seals where components meet, as poor connections or damaged parts often lead to system pressure loss. During this inspection, utilize diagnostic tools or smoke tests if needed to pinpoint any areas of compromise effectively. If leakage is found, it's crucial to repair or replace the affected components to restore system integrity. Proper evap functionality can directly impact the turbocharger's performance, making this inspection essential. The sixth step in resolving the P0299 code involves a detailed inspection of Boost System 1, which links the turbocharger to the throttle body. This pathway must be free of any blockages, restrictions, or leaks that can impede airflow. During this inspection, examine all component connections, hoses, and joints for signs of damage or misalignment. Even minor imperfections can lead to significant performance issues. If any leaks or blockages are identified, they must be addressed immediately through repairs or replacements as necessary. Effectively maintaining Boost System 1 is vital for achieving optimal performance and preventing recurrent underboost conditions in the turbocharger system. For the seventh step related to code P0299, inspect Boost System 2 thoroughly. This part of the system also influences the air supply to the turbocharger and throttle body junction. Attention should be paid to all connections to ensure there are no restrictions or damages that could affect airflow. Inspect hoses and fittings, as these become wear points due to engine vibrations. If any problems are detected during the check, it will be necessary to resolve them to restore proper function. Ensuring that Boost System 2 operates efficiently has direct ramifications for overall turbo performance, underlining the importance of this step in troubleshooting. Step 8 of the troubleshooting process focuses on the exhaust system, which plays a vital role in the turbocharger's functionality. Inspect the components between the engine and the outlet of the muffler for any signs of leakage. Leaks in this area can adversely affect exhaust flow, thereby impacting the turbocharger's ability to generate adequate boost pressure. It's essential to inspect every joint and fitting for potential issues. Any detected leaks will necessitate repairs or replacements to restore the system's integrity. A well-sealed exhaust system is crucial for optimal turbocharger performance, ensuring that the engine can achieve its intended boost. In the 9th step, it is necessary to conduct a functional inspection of the turbocharger wastegate control actuator. This component regulates the flow of exhaust gases through the turbocharger, which directly impacts boost levels. Using the Honda Diagnostic System, HDS, perform relevant tests to ensure that the actuator engages and operates as designed. Visually inspect the actuator for any identifiable faults, such as corrosion or misalignment. If any issues are found during this examination, or if it fails to perform correctly in tests, replacement of the actuator will be warranted. A healthy wastegate control actuator is essential for effective turbocharger operation and maintaining target boost levels. The 10th step involves inspecting the turbocharger bypass control solenoid valve. This component plays a crucial role in turbo management and should be evaluated through functional testing. Using the Honda Diagnostic System, HDS, execute the TC bypass control solenoid valve test to confirm correct operation. Ensure that the solenoid makes a clicking noise when energized, indicating it is functioning as expected. If the valve does not produce the expected sound or shows erratic behavior, it may require replacement. A properly operating bypass valve is essential to maintain the necessary boost pressure under various driving conditions, thus directly impacting the performance of the vehicle. The final step requires performing a thorough PCM, Powertrain Control Module inspection. This module is responsible for processing data from various sensors and controlling engine operation, including the turbocharger's performance. If all previous components have been verified as functioning correctly, and the DTC still persists, the PCM may be the underlying source of the issue. Perform diagnostic tests using the appropriate Honda equipment to assess the status of the PCM. If faults are present, replacement will be needed. Addressing PCM issues is crucial for resolving long-term performance and operational reliability in the Honda CR-V. A malfunctioning PCM can lead to persistence of DTCs due to improper signal processing. After performing all identified repairs or component replacements, a final verification step is critical to ensure the DTC P0299 has been accurately resolved. Begin by clearing any stored DTC codes from the PCM and resetting the vehicle's systems. It's then essential to conduct a road test to observe how the vehicle behaves under various conditions, specifically focusing on engine power and responsiveness. During this test, monitor key performance metrics such as turbo boost levels, ECT sensor data, and the behavior of the exhaust system. Confirm that the previously noted symptoms, such as reduced engine power and turbo lag, no longer present themselves. Successful verification ensures that any underlying issues were effectively addressed, restoring the vehicle to its intended performance levels. Preventive maintenance is crucial for avoiding future occurrences of the P0299 DTC. Start by regularly inspecting the air filter for restrictions or dirt buildup, ensuring optimal airflow to the turbocharger. Keeping air intake systems clean significantly enhances turbo performance and longevity. Additionally, regularly inspect hoses and connections for wear or potential leaks. Timely identification and repair of these components can prevent issues down the line. Engage in routine cleaning of the turbocharger system, focusing on the bypass valves and actuators to ensure they function smoothly. These preventative measures contribute not only to the reliability of the turbocharger, but also to the overall performance and fuel efficiency of the Honda CR-V. In conclusion, the P0299 DTC represents an essential area of concern for Honda CR-V owners, especially regarding turbocharger performance. This code signifies issues that can lead to reduced engine efficiency and power, pinpointing the importance of thorough inspections and troubleshooting steps. By following a systemic approach, beginning with basic inspections and moving toward more complex component testing, technicians can accurately diagnose the problem. Regular maintenance practices not only prolong the life of the turbocharging system, but also ensure that similar issues do not arise in the future. Ultimately, addressing the P0299 code efficiently solidifies the reliability and performance integrity of the Honda CR-V, enhancing the driving experience. Please like and subscribe to the channel. See you next time.